Oh my gosh, that's creepy. Okay, so this is your lesson video today, even though I'm playing with the Zoom right now. Hold on. So I wanted to teach from the board today and have you, because we're doing multiple transformations, so I wanted to be sure you could see me pointing, like talking about reflections or where the points move. So I'm recording the video today of me at the board. I tried doing this in all 3 class periods today and failed some part of the technology in every single one. So that's why the video hasn't been posted yet today, and I had to wait till after school to make it. All right, so let me be sure I know how to pause and everything that I need to do from the Zoom. Hold on one second. Okay, just one more plaything. Okay, I'm over it. Okay, I'm over it. I think I'm over it. Let me get this off. Okay, so if you're taking your own notes by hand, I want you to pause the video for a second and write down everything that you see on this screen, okay? And then for those of you who have the notes printed, or you already got your notes while you were on campus and maybe now you're just rewatching the video, these were the things I added on to the printed version. I added this right here with the 1, 2, 3 labeled, and then and that coordinates with this 1, 2, 3 here. So what we did on Tuesday, I should say, let's skip back and talk about Tuesday. On Tuesday, we had 2 lessons, and the first one was where we reviewed some parent functions. We had 6 basic functions, and they were identity, y equals x, x squared, x cubed, square root, cube root, and absolute value. And we spent the first lesson reviewing their shapes and their and some good points or ordered pairs to use for graphing them. Then the second lesson we did on Tuesday was transformations of those, but only one transformation at a time, like down or up, maybe left or right. What we're going to do today is multiple transformations on one of those parent functions. And since there's going to be more than one, we have to talk about the best order for doing them. And so that's what I've done here by labeling the horizontal shift, the X, as your first thing to do. Any A values out front will be the second thing. And then your vertical shift, whatever's being added or subtracted all the way out to the end, that's the third and last thing that you're going to do. And then you can kind of think about this like, it's kind of like following PEMDAS, the order of operations. Take care of what's in parentheses first, and then multiplication next. That would be your A. And then addition, subtraction last, which would be your vertical shift. Another way I like to think about it is you're working from the inside out. Like if you consider X right here on the inside of the parentheses, you're going to do, and you're working from the inside out, you're going to be doing the H first, and then A is the next closest thing, and then out to K, which is the farthest thing. So closest, next closest, farthest, as in relation to the X. All right. So keep those things in mind as we talk about these transformations. So right here, what we have is a function, negative 2/3 x plus 2. And then we have 2 choices that it could be. So let's talk about the different modifications in the parent function and then which of those it would be, all right? So first thing I want you to think about is to look at this function and try to determine which of our 6 basic functions it was before it was modified, before numbers were added to it and negatives were added to it. And that's this right here, just x. So the parent function, y equals x, okay? And that shape looks like this. Then the modifications that happen to it are these. There's an a value. There's no h value, by the way, right? There's nothing, an h would be in parentheses with the x, but there is no h value. So then we skip to the a value, which is this one, and then the +2 at the end would come last. And so these are the things happening to the original shape. The y values are all multiplied by 2/3. That's a compression or a shrink. Not like a psychologist, right? But it gets shrunk. You got shrunk, tiny toilet. Isn't that right? That's from a, what's that movie called? With Gru? Something neat. Oh, Despicable Me. Yeah. You got shrunk, tiny toilet, something like that. Anyway, so then 2/3 means your y values are multiplied by 2/3, so they go from being here to being lower, right? They shrink. The negative right here, when you have a negative out in front of the entire function, that means you're taking the opposite of y. So if your y is positive, it's going to become negative. If it's negative, it's going to become positive. So this is a reflection over which axis? The x-axis, right? So opposite of y means reflect over x. And then this +2 at the end means your graph is going to go up 2. So looking at these two functions, which do you think reflects over y, shrinks, and went up 2? Pause the video and think about that. Now you should be unpaused if you paused it. And it's this one right here, right? This one, you can see that it went up 2. This one went down 2, okay? Pause the video if you need any of that, because I'm about to erase it. All right, this one. What do you think the parent function is before? What was the basic function before numbers were added, before any negatives were added? What do you think it was? I hope you thought square root of x, right? That's before any changes happened. And that parent function looks like this, right? So let's talk about the modifications that happen to it. The first one is this +6, and the second one is this minus out front. So the +6 is inside the absolute value with the x. So this is an insider's lie situation. And it means that instead of adding 6 to all the x's, we're going to be subtracting it. That means it's moving to the left 6 spaces. And then the negative out front again means you are taking the opposite of y. So if it's positive becomes negative, negative becomes positive, it's reflecting over this line. So it's reflect over x. So take a minute and think about which of those went left 6 and reflected over x, and pause the video if you need a second to think about it. Okay, now that you've unpaused. They've both gone left 6 from the original, but this is the one that reflected over x. So this is the original shape. Going to the left 6, get it here, but reflecting over x is this one right here. So this is the answer. That one went left 6, but it didn't reflect over anything. So pause your video if you need another second to look at that, because I'm gonna erase. Okay, pause the video and try this one on your own. So the parent function is absolute value of x, right? That's what we would have before any numbers were introduced into it. And the absolute value of x parent shape looks like that. Okay, it's a V. And so you see both of these are V's, right? So here, how many transformations do you see? How many times has it been modified? 2 times, right? There's a -2 and there's a -5. Which one, if we were graphing this from scratch and we didn't have these 2 to look at, which would we do first, the -2 or the -5? -2, right? This is our H, this is what's inside the X. All right, and so that first modification is an insider's lie. That means you're going to take your parent shape and move it to the right 2. And then -5 on the outside, round the outside, round the outside. That means down 5. Okay. So which of those shapes took the parent function and went right 2 and down 5? This one, okay? They both actually went down 5. This is the only one that went right 2. And this is the end of the first section of your notes. On your homework, what the problems you have that are like this, you have a bank of problems. You have like 6 equations or something, and you're going to match the equations to the shapes. There are more graphs than equations, so you won't use all the graphs. But this is the basic idea behind the first section of your homework, okay? For the rest of the lesson, we're going to be doing our own graphs. We won't be matching to graphs. We'll be doing ours all by ourselves. All right, so these are the instructions for the next several problems. You don't necessarily have to write them down, but I do want to point out the main things that this is asking us to do. So we're going to graph each function using shifts of a parent function, right? And a few points, characteristic points. Those are the points we talked about on Tuesday or Monday, depending which class you're in, when we made that little packet of the library of parent functions. And then we are going to state and indicate the transformations that we used. So we're going to write down, did we go left, did we go right, up, down, like what we did. And then identify the points. Remember we had those vocabulary words where they each have a different special point, like it's a vertex or it's an inflection point, or the absolute value. No, sorry. The square root graph had an initial point. So we're going to put the ordered pair for those points, okay? And remember, it's like PEMDAS. You do the transformations in the parentheses first, then the multiplication, if there's an A value, and then any addition or subtraction that's at the very end. Okay, this is a good way, like a good little trick to remember the order. Okay, here's the first one. So absolute value of x minus 3. So let's first talk about what the parent function was before any numbers were added to it. Hopefully you said square root of x, right? And then this is the shape of the parent function. And there were 3 of the characteristic points that we talked about in the last lesson that we use for this shape. And it is 0, 0, 1, 1. And then what's another number that's easy to take a square root of? 4, right? And square root of 4 is 2. So that's our basic parent function shape. So now let's identify the transformations. There are 2 modifications that have happened to the square root. There's a minus 3 and there's a plus 2. Think to yourself for a second, which one of those are we going to do first? The minus 3 or the plus 2? Minus 3, right? That's our h value that's inside the square root with the x. So we're going to do this one first and this one second. So our first transformation is the negative 3. It's inside with the x. So this is an insider's lie situation, which means we're going to be going right 3 instead of what looks like we should be doing left, right? And then the second thing is a plus 2. That's a vertical shift. You're adding 2 to all your y values. So we're going to be going up 2. So what you can do is you take each of those 3 characteristic points, you go right 3 and up 2, and you make your new point. So I'm going to do 0, 0. I'm going to go right 3, up 2. And then take the 1, 1 point and go right 3, up 2. And then do the same thing with the 4, 2 point. Right 3, up 2. And this is my transformed shape. And the ordered pair for this special point, do you remember the name for this special point for square root? Is it vertex, inflection point, or initial point? It's an initial point, right? That's where it begins. That's where it starts initially. It initializes, any other way. That's the initial point. So what I just did was a very systematic way of doing it. I took those 3 points and followed the same order of transformations for each one. Another way that I actually do this myself to make it kind of go faster, you don't have to like this way. If you're a very systematic person, you just do it point by point, and you're gonna be gold, okay? But if you like to think of things maybe in patterns or going a little bit faster, you can do this. Still take your first point and shift it, right? 3, up 2. But now, notice there's no A value. There's no stretch or compression. Think about this as your new 0, 0. Like this is your new origin. And then now just do your points, your 1, 1 and your 4, 2 from here. So you're going to go over 1, up 1, and then come back and go over 4, up 2. It gets you the exact same shape. Okay, that's just kind of a faster way. And you absolutely don't have to do the faster way. You can do the shorter, longer, not shorter, but the longer way. Like it just doesn't matter. Whichever you like, okay? Pause it if you need that screen up anymore. Otherwise, I'm about to skip to the next one. So I'm going to talk you through the setup of this one and then ask you to pause while you try to graph it yourself, okay? First, think about what is the parent function before any modifications happen. Pause it if you want to keep thinking before I answer, okay? I hope you came up with x squared. Your clue is this 2 right there, okay? It was x squared before it got the -2, the negative out front, and the +5 on the end, right? And then the parent function for x squared is a parabola. So if I graph that over here, the 3 points I like to use are 0, 0, 1, 1, and -1. Okay, spent way too much time drawing now. All right. Sorry, I don't know. Blah. Leave it alone. Okay, so now look at the modified equation, the transformed equation, and think how many places has it been modified or changed? How many do you see? 3, right? So there's 1 here, right? At the -2, you're going to start inside, that's your h value. And then you go 2 to the a outside, which is a negative. And then 3 is this last one, the 5. So here's our order of transformations. The first one, a left, so this is insider's lie. So it's a -2. You're going to do it's lying to you. So you're going to do the opposite, which is go to the right 2. Okay. You're not subtracting 2 from x, you're doing the opposite, which is right. And then a negative on the outside means you're taking the opposite of your y values. So if your y was positive, it becomes negative. If it's negative, it becomes positive. So this is a reflection over the x-axis. So you're going to reflect over x. And then the third thing, the +5 on the end, is a vertical shift. You're going to go up 5. So I want you to pause the video and try this on your own before you watch me do it, okay? All right, so hopefully you tried this on your own. I'm going to take these 3 points and follow those transformations, okay? So starting with 0, 0, I'm going to go to the right 2, which gets me here. Reflecting over x doesn't make a difference here because I'm on the x-axis, so it's just going to stay. And then I need to go up 5. 1, 2, 3, 5. So I'm going to do the same thing with the other 2 points. So starting with negative 1, 1. So I'm right here. I'm going to go right 2. Gets me here at 1, 1. Reflecting over x means right now I'm 1 above x. To reflect over means I want to be 1 below. So that puts me right here. And then I need to go up 5. 1, 2, 3, 4, 5. And then for the 1, 1 point, I need to go right 2, which has me here at 3, 1. Reflecting over x, right now I'm 1 above x. Reflecting means being 1 below. So I'm right here. And then I need to go up 5. 1, 2, 3, 4, 5. Okay. And so, and the vertex point is at 2, 5. Right? That is your systematic way of doing it, point by point transformations. Let me show you a kind of faster way. Once you get your, so this was my transformed 0, 0, okay? I know from this negative that instead of opening up, my graph is now going to have to be opening down. And I know that there's no A value here to change if it's being stretched or shrunk. So since I know it's going to be facing down, going the opposite way, I can just do my 1, 1 points. 1, 1, 1, 1. So it's like this is my new origin, my new 0, 0, and it's facing the other direction. But the pattern of the points and the symmetry stays the same. Okay, so if you like that sort of more mental imagery type way of doing it and that in your brain works like that, that's okay. My brain doesn't quite work like that. Like in school, I did worse at geometry than algebra. If I was learning this for the first time, I like the systematic approach of doing each point 1 step at a time. And in the next problem, when it's even more complicated, I'll show you an even more systematic way for you in case you like that. Okay. All right, so take a moment, look at this parent function and figure out what the, sorry, this is not a parent function. Look at this modified or transformed equation and figure out what the parent function was. I hope you said x cubed, right? Because of that 3 right there tells you that's your clue of what the original function was. And x cubed looks like this. Okay, and we're going to use the points 1, 1, 0, 0, negative 1, negative 1. Okay. All right, so look at that function, pause the video if you need to, and answer this question. How many modifications have been made to the parent equation? How many modifications have been made to the parent equation? I hope you said 4. Okay, so here they are. There are 2 going on inside the parentheses. I'm going to call the +2 1, because that's how we numbered it at the beginning of the notes. We numbered it 1, we numbered the A value, we numbered 2, and we numbered the K value out here 3, all right? But there's this negative inside here, so I'm going to call it 1A. So the ones will be whatever's in parentheses. Now, I told you that when you're trying to do the order of transformations, it's like PEMDAS, right? You do everything inside parentheses first. But this time, we have 2 things inside parentheses. So in case you're wondering, well, which of those do I do first, the +2 or the negative? It's always going to be the +2. It's always going to be your H value, your horizontal shift, okay? Then you can do that negative in front of the X. And so we'll talk about what that means in just a second. Let's list the transformations. Oh, I think on the last screen, I forgot to put the ordered pair for the points. So sorry, but I'm sure you can do it. I don't think I've deprived you of something too hard. So here are the transformations. The first one, the +2, is an insider's lie. So that means you go left 2. 1A, so here's a negative. We've done problems with negative already today, but those negatives were here. When the negative is on the outside, you're taking the opposite of your Y values. When the negative is on the inside, you're taking the opposite of your X's. So if your X is +3, it becomes negative. If your X is -6, it becomes +6. So this is the reflection that's going on right now. What is it reflecting over? It's reflecting over the Y-axis. So this is going to reflect over Y. The second modification is the A value is 3. This is what we call a stretch. So this is a stretch by 3. What that means, practically speaking, because you might be like, oh yeah, stretch by 3. I don't know what that means. It means this. You're going to multiply Y values by 3. Okay, I don't know if you can see that. Multiply Y values by 3. I don't know if I just messed up. Hold on, I have to look at my Zoom screen and see if I messed it up. That didn't work. Never mind. Okay. So multiply, I don't know if you can see that. Multiply Y values by 3. And then the last one, the third step, which is really 4th step, is down 1. So I want you to pause the video and try that yourself before you come back to see how I do it, okay? All right, so here's how I do it. And I'm going to show you a very systematic point-by-point approach for problems like this where there's a lot of steps going on, all right? So starting with 0, 0, let's talk about the first transformation, left 2. So it takes 0, 0 to the -2, 0. So it goes from here to here to -2, 0, right? It changes your X value. Then we need to reflect over Y. So it means I'm taking the opposite of whatever X is. So here's my -2, 0. It's 2 this way. Reflecting over Y means it needs to go 2 that way. Or if you're doing it point by point, you're just taking the opposite of X. That's what this means, opposite of X. So the opposite of X here is +2, 0. Okay, so now I'm right here. Then I need to do stretch by 3, and I said that means multiply your Y values by 3. So you take this point, you multiply the y value by 3, okay, but it's just still 0. So we're just going to stay here. And then go down 1. So that changes your y value and lands you here, right? To -1. I'm going to erase those now and do another point, just like that. Now, this is not necessary. If you are a good person, if you're good at picturing shapes and space and movement, you probably don't need to do that. But if you're not good at it, then rely on this right here, okay, 1 point at a time. So let's do 1, 1 now. I'm going to go left 2. That gets me right here at -1, 1. Reflecting over y, so it's 1 this way. Reflecting over y means 1 this way. So that now it's at 1, 1. Okay, I did the opposite of x. So x was -1, now it's +1. Then stretch by 3. That means multiply your y value by 3. So now I'm at 1, 3 right here. And then the last thing is to go down 1, which makes your y value go down. Pause the video if you need to catch up with any of that. Now, once you get this point here, you can probably deduce that the third point's going to be a pattern between these two. Like this from here to here goes down 3 and over 1. So if I do that again, over 1, I would get my third point. And then you can see how this x cubed graph has been stretched, right? The 3 has stretched it longer, and it's been reflected. But, and if you're good with that, you can stop the video. But if that was too loosey-goosey for you to get that third point, and again, you're that systematic approach person, let's do the points for you real fast, okay? So starting with our -1, -1. Moving left 2 means subtracting 2 from your x value. So that gets you to -3, 1 here. Reflecting over y means if you're 3 in this direction, reflecting over y means you need to go 3 in this direction. Okay, it means you're taking the opposite of your x value. Sorry, I was here. So 3 this way means 3 this way. So you're at 3, -1. You took the opposite of your x value. And then stretching by 3 means multiplying your y value by 3. So this becomes 3, -3. 1, 2, 3. -3. And then down 1 gets you right there where I said it was going to be. Okay. And the new inflection point is 2, -1. Which reminds me, if you had a different math class where you were taught to factor out a -1 right here, you are still welcome to do that. The only reason I'm not teaching it is because it's like a whole other layer to teach on top of this other stuff. This stuff works fine. Okay. If you are the factor out -1 person, you would look like this right now. You would factor that -1 out to the 3, which would change your parentheses to x -2. And then look at what that gives you. That gives you a 2, -1 inflection point, right? I got 2, -1. And then instead of going, and then you have a -3 A value. So it would bring your 1, 1 point down here, and then your -1, 1 up there, because it would reflect it, right? So I'm just not going to be teaching that way. I'm just going to teach the one way. But if you can remember this method from other math classes, you're welcome to do that. Okay. So that is it. Let me stop my Zoom. Hopefully this worked.